Hey guys, welcome back to another episode of Math Unlocked, and I'm your favorite host, Mrs. Rhodes-Grierson. Today we're looking at the laws of indices, and we want to put this in a nutshell. We want to ensure that we understand it in its simplest way and what it means. So let it make some sense, all right? So we have the number 5 raised to the power of 2. This is what we call our index, the power. You layman terms, power, also considered index, so laws of indices. So the laws of indices has to do with our powers. Then a number, which is the base, a number is raised to some power. What does it mean? So indices allows us to just condense some statements that we have a number multiplying itself. Itself. So the number is 5. 5 is multiplying 5. How many times? The power tells us how many. So 5 is multiplying itself twice. So 5 to the power of 2 means 5 times 5. So therefore means that somebody would let's say we were writing 2 times 2 times 2 times 2. I realize that it's the same 2 multiplying itself. So instead of writing 2 so many times multiplying itself, I could condense that statement and say, how many times is 2 multiplying itself? So 2 is multiplying itself. I'm counting 1, 2, 3, 4. 4 times. So this power becomes so important because what it does is that it's saying to us that this base was multiplying itself 4 times. So I do not need to write it out. I could just write that 2 is raised to the power of 4. So let's look then at the first law of indices. Now let's check this. What if I gave you the expression 2 to the power of 3 times 2 to the power of 2? Notice that these bases are the same, and what did we say this meant? 2 to the power of 3 meant 2 was multiplying itself 3 times. So that would have been 2 times 2 times 2. And this is multiplying further by another 2 times 2. Now remember what an index does, that it allows us to write a base that is the same base. And instead of writing it out so much time, we just tell them how many times was it multiplying itself. It's the same 2 multiplying itself here. But now I realize it's multiplying itself 5 times. So what does the first law look at? Let's observe what's happening here. 2 is raised to the power of 3 times 2 is raised to the power of 2. That really means 2 was multiplying itself 5 times. So if it is that I'm continuing to multiply the same base, what I could do is just to add these powers. And notice I said, if I am multiplying, operation multiply, and it is the same base, so it's conditional. 1, multiplication must take place. 2, it must be the same base before I can then decide. Just add the powers, because what I'm doing is to say how many times that base was multiplying itself in a nutshell. All right, let's continue again now. Look at this expression. What if I'm asked to simplify this expression? Well, when I look, first I'm going to check out what operation is taking place. Because what we just looked at was that, what if I am multiplying and the base is the same? I would then add the powers to indicate how many of that base was multiplying itself. Now, this is a base of 5 raised to a power of 3, which means that 5 was multiplying itself 3 times. It's then multiplying 3 to the base of 2. A base of 3 to the power of 2. These are not the same base. So because it's not the same base being multiplied, I couldn't say it is multiplying itself there, because it's not the same base. But there's another 5 here. This 5, I'm not seeing a power on it, which means it's just 5 to the power of 1. So remember that, guys, remember that. Once you don't see a power, it's 5 to the 1, which means that there's just 1 5. It's not multiplying anything there. It's just 5. Now, I can then put these together because it's multiplication and these bases are the same. So if I've already had 5 to the power of 3 here and I'm further multiplying it by another 5, it means therefore that it's now going to be 5 to the power of 4. What is that multiplying? This base of 3 is multiplying this base of 3. All of them is multiplying, but I can only put the ones that are the same together. So this base of 3 is multiplying this base of 3. And since this was 3 times 3 already, that's 2 of them, and there's 4 more over here, I can condense it to become 3 to the power of 6. This now can't be further condensed, because these bases are not the same. So because of the fact that laws of the index tells us how many times the base was multiplying itself, since these bases are not the same, I can therefore stop right there. All right, so let's go into the algebra of it now. What happens when you get an expression that have letters in it now? Let's look at this. Now I have the number here, 5. P to the third power, Q to the second power is multiplying 2. P to the, you can answer that before I put it there, P to the power of 1. Notice that the power is written to the top right hand corner. I can't just decide to drop it anywhere, because the rule says if I'm representing that it's an index, I must put it to the top right hand corner. So all these powers, I can know which base it's attached to based on where the index is. So I would know that this 3 is not on the Q, because it's to the top right of P. I know that the 3 here is assigned to the P, and the 2 here is assigned to the Q. Now I'm multiplying. I am multiplying. What am I multiplying? Now I notice that this is 5. There's no power on it, so I know that it's a power 1, so it's just 5. This is just 2. There's no power on it, so it means that this number is just 2. That means I could say 5 times 2. Now notice before, with the ones that were had different bases, I didn't multiply them because there were powers assigned to the index that didn't allow me to multiply them. But this number is just 5 because there's no index. This number is just 2, so I can say 5 times 2 will give me 10. That can be simplified. Now I'm going to look at what happens when I have a base of P here to the third power, base of P here to the second power. Since they are the same bases, and the law said the base must be the same, so whether or not it's a letter base or a number base, the base is the same. So since the base of P is the same, and this is P to the third, multiplying P to the first, that will now give me P to the fourth. I added them. Q now. Q had a second power on it, multiplying Q to the fifth power. I leave the base of Q, same base. I'm going to add my powers. So I added these, and I will add these. I'm doing addition because once the bases are the same and we're multiplying, we can go ahead and add up the powers to see how many. So this becomes the power of 7. And that is simplified. Of course, I will leave one with you. So here's yours. Here is yours. You're going to try this. Simplify this expression using the multiplication law of indices. Post your answers in the chat and let's work this together. Don't forget to like and subscribe if you have not yet done so. So let's continue to work now and in the future.